Alright, this lesson is going to be creating this bolt and nut assembly, and when you're done you should be able to animate, and as the nut revolves it also travels up the bolt just like in the real world it would. So that's our goal by the end of the project, to have this assembly animated. Alright, let's get started. First we're going to go ahead and create a new project. I'm just going to call it nut and bolt. First thing I'm going to create is the bolt. So I'm going to create a sketch on the top plane, and the first thing I need to create is a cylinder. So I'm just going to create a simple circle attached to the point of origin. I'll go ahead and dimension this and have it be 10 millimeters. What's the no, I want the diameter to be 10. Right, there we go, 10. Now I need to extrude this. And let's go ahead and make this 50 millimeters. And then click the check mark. So we have our first part. This is eventually going to be the bolt. So I'm going to go ahead and rename this bolt. So all I need now is some threads to create my bolt and a hexagon head. So let's go ahead and model that head first. Go back into, let's go ahead and create a new sketch. So I need a sketch. I'm going to choose the top of my cylinder as the sketch plane, and I'm going to draw a hexagon. So this tool acts like a circle tool. Just hover over, place that right in the center, drag away. I like to have mine aligned either vertically or horizontally with the drawing plane. So there we go, there's a vertical, and I want this to be 6-sided, so as I scroll left to right I can increase or decrease the number of sides. So I want it to be 6, and then I'm going to go ahead and dimension this and have it be, say, 15. Then I want to extrude this. Let me reverse the direction and have it not be so big. Let's go 5 millimeters. And because it's touching an existing part, it's assuming I want to add to the part, which I do, so I'll click the check mark. Alright, now, so now I have the solid material for my bolt, and all I need to do now is remove a thread pattern. So now I'm going to start the process of making a helix, which is the curly Q type shape, like the spring shape, that's going to create the threads. Okay, so now I need to find that helix tool. I think it's found in this drop menu. Yes. So it's this tool here, the helix. And to create a helix you need to have either a conical or a cylindrical face. So either a cone shape or a cylinder. So I have this cylinder, I'm going to click on it and it places the helix right on that. Now I can change the direction of rotation, but this is the direction that I want it to be. And then I can change the number of revolutions. So so it's 50 millimeters. Let's go ahead and do 20 revolutions. That looks pretty good. So that means 50 divided by 20 is 2.5. So there's 2.5 millimeters between each revolution, which is an important number to remember. Alright, so I'm done making my helix. I'm going to click the check mark. And now I want to hide my bolt, so I can just focus on this for a second. I'm going to create a sketch and I want to be perpendicular to the helix. So I'm going to be using either the right or the front plane, and I want it to be attached right here at the end. So the front plane is the one I want to use. So I'm going to create a sketch, choose the front plane, and the first thing I'm going to create is a construction line. So I'm going to use the line tool, change it to construction. I'm just going to draw a line from the center point out to the edge of my helix and attach that there. Now there's a whole science to threads. I'm just going to use a basic triangle to cut out my threads here. So we're going to start modeling a triangle. Let me view normal to the sketch plane, and I'll press the P key to hide my planes. And I'm going to start with just a line out here in space somewhere that is aligned vertically, and then I want to attach this line from its midpoint to this point in my drawing. So I'm going to use the midpoint constraint, click on my line, and then click on that point to attach it there. I'm going to dimension this, and this is very important. So this is the distance between, if this is going to revolve around this helix, it can't overlap itself. So I have a distance of 2.5 millimeters. So it has to be less than 2.5 millimeters. So I'm going to make it 2.499, which will be basically touching but not touching. Press enter. And then now I can complete my triangle by creating the other two lines here. So I'm going to click this and have it attach, and then finish off the triangle there. And now I can dimension this side if I want this to be more sharp. I could increase the value. Let's go ahead and dimension. Why don't we just do this? Click that distance from there to there and make it 2.5. Alright. Now I have the outline of my shape, so I'm going to use the sweep tool. Let me go ahead and accept my drawing. I'm going to use the sweep tool to sweep this shape around the helix path. So I need to select the face, was the first step that I did. Select the triangle. And now I'm going to switch to the sweep path and select my helix. You can see right away that it successfully made that. And now I have a new part 2. Click the check mark. We're going to rename part 2. Name this threads. Now what I need to do is simply use the threads to subtract from the bolt. So I'm going to use the Boolean tool. I'm going to use the subtract option. The tool I'm going to use will be the helix, so I'm going to use the threads as the tool, and the target is going to be the bolt. And you can see that it has removed from the bolt, but let's see, it's also removing a bunch of material inside the bolt head. So instead of going through the hassle of like going back in time and doing just the cylinder and before I create the head of the bolt, I'm going to just place this boolean before the extrude part. Let's see if that works. Let me go ahead and press the check mark. See if I can move this in order for the extrude. Nope, that breaks it. Let's go ahead and go, let's see if we can do something different here. This was the part that made the head of the bolt. Let's go into this. And instead of adding, we're going to create new. That keeps the cylinder separate. Alright, now I want to do the Boolean operation to add the head to the bolt. Hopefully you're following along with me here. So let's use Boolean. Now I have the head of the bolt and the bolt. So I'm going to add or union these two together. Press the check mark. Okay, so now because that happened after the other Boolean, so it's creating the threads and then it's adding the head of the bolt. So that looks a little bit more natural. Let me go ahead and hide the curve because we're done with that line there, the helix. Alright, so here at the bottom I have something that I'm not super pleased with. So this shape is not normal to what a bolt would look like. Usually this would be tapered off on the end so it can screw in to the nut. So I'm going to hide or suppress this Boolean operation where I created the threads. So I'm going to suppress this. So I should be able to see my cylinder now. I'm going to hide the threads. And what I want to do is taper this off. I'm going to be using the chamfer tool for that. I'm going to click on the edge of my cylinder. And it's already chamfering it 5 millimeters in both directions. Because this is a 10 millimeter circle, 5 millimeters in from the radius would be a perfect point there. That's too sharp. So I'm going to just change the value here to see what happens. If I go down to 3, that's starting to look a little bit better. But what I want to do is change both the distance from the radius inward and the distance from the end of the cylinder upward. So I can change this from equal distance to 2 separate distances, and I can adjust each one individually. So this measurement up the cylinder, I want this to be at least the distance of one thread. So that's 2.5 millimeters. So I'm going to find out which one this is. Let's do 2.5. Okay, that is the one that I wanted to adjust there. And now this one, I'm going to, let's just play around with the measurement and do 1 millimeter. See what that looks like. Actually, this one I want it to be half of a rotation. So 2.5 would be the full thing. I only want half of the triangle cut off. So let's do 1.25, and let's do 2 for this one. Alright, that looks good. Click the check mark, and then I'm going to unsuppress the Boolean and see what we have. Alright, that looks a lot better. There's still a little bit of something here that it's not very good. I'm going to go in and change that chamfer again. And I think I want to go in just a little bit more. 2.5. There we go. That looks much better. Alright, we're done with the bolt. Next we're going to design the nut. So I'm going to create a different part studio for this. I'm going to click on the plus symbol, go into the parts studio, and I'm going to simply draw a hexagon. It's the basic shape of a standard nut. So I'm going to create a sketch on the top plane. Use this polygon tool. Click on the point of origin. I like to align it either horizontally or vertically in the drawing area. I'm just going to click to place it, and then if I scroll to the right or to the left, I can change the number of sides. I want 6 sides. Then I'm going to dimension this, have it match the head of the bolt, which was 15 millimeters. Then I just simply need to extrude this. And let's say 7 millimeters, just a little bit thicker than the head. That looks pretty good. Click the check mark. And what I want to do now is use the bolt to subtract from the nut. So to get the bolt into my current part studio, there's a special tool for that. So I need to expand my list of tools here. And I'm looking for the derived tool. So I click on that. This brings up the menu of the different part studios I have, and I can choose what part from there I want to import, which would be this, the bolt. I click the check mark, I'm done importing objects. Alright, now I want to use the bolt to subtract from the nut. So I'm going to use a Boolean operation. The tool I'm going to use will be the bolt. So I'm just going to go ahead and select that from the list. And then I want to make sure I'm subtracting. The target is going to be part 1. Click the check mark so I can see what's happening here. So already you can see there's a couple issues. One, because the tip of our bolt is tapered, that circle at the bottom is not going to allow the bolt to screw all the way through. And then you can see at the top here, this shape is not open and readily available to receive the bolt. So I want to change a couple of things about this. First, I want to make sure that my bolt is, I'm going to change the position of it so that the threads are penetrating through this all the way completely. So the nut is like halfway through the bolt. So we get a nice uniform thread pattern without the taper on the bottom. So I'm going to suppress this Boolean for now, which will bring my bolt back. And I want to transform the placement of the bolt. So I'm going to select the bolt, use the transform tool. I want to translate by XYZ. Specifically, I want to translate by Z. So since I'm in this mode, it gives me these directional arrows, which are really helpful. I can just grab one of these and drag in the direction I want to go. So I just want to drag that bolt down. Press the check mark to accept the transform. And now I'm going to unsuppress the Boolean that I did before. And if you get this error, so the transform is red, so the transform needs to happen before the Boolean. So I need to have the placement of the bolt before the Boolean. So I need to just grab this operation and move it in the order of operations ahead of the Boolean. So now the bolt is moved down and then it performs the subtraction. So now I can see the results. So I got rid of that problem on the bottom, but there's still a very strange shape here at the top and bottom. So what I'm going to do now is taper, like we did the bolt. I'm going to add a chamfer to the edge to get rid of that problem. Before I do that, I need to have a hole in my nut that I can chamfer. So again, I'm going to suppress this. I'm going to hide the bolt for a moment so I can just focus on this general shape. So I want to create a hole in here so I can chamfer it. To go into my original sketch, I'm simply going to add a circle. Go ahead and dimension this. And mathematically, when I drew the triangle for my threads, if you remember, it was 2.5 millimeters inward. So if I have 2.5 millimeters inward here, and then on the other side I have 2.5 millimeters in, that's a total of 5 millimeters. So that's where my thread is. So I don't want to create a hole that extends beyond the threads, but I have 5 millimeters to play around with. So I'm going to go ahead and dimension this to be 5 millimeters. Alright, so that because I drew this, it's assuming that I wanted to remove that before I did the original extrusion. I'm going to press the check mark and see that that actually happened. Now I'm going to taper the edge by using the chamfer tool. Click on the edge. I'm going to adjust this to be 2 distances. Let's see. So one of them was 1.25, and then the other we had a measurement of 2.5. Just doing the same measurements as the bolt. Go ahead and apply that to the other side of the nut. There we go. Press the check mark to accept that. And I'm going to unsuppress this. And again, I get an error. I simply need to move the chamfer before the boolean. I can see the results here. That looks much better. Alright, so now I'm done with this. I'm going to go ahead and label it. This is the nut. And now I'm ready to do my first assembly. So I'm going to go into the assembly workspace, and where you would normally see the sketch button, you see the insert, which is before you can do anything you have to insert some parts. So here I see both of my part studios, and if I clicked on one of these, it would import everything inside the studio. I don't want to do that. I want to expand, so now I can choose exactly what I want to import. So I'm going to click and insert the bolt. I'm just going to go in some random spot and click. I'm done inserting parts for now, so I'm just going to click the check mark. And the first thing I want to do is lock this into position. I'm going to put the end of the bolt right here at the point of origin. I want to make sure that it's pointing up, which it is. It was drawn that way, so it came into here facing the correct direction. So I just need to mate this with the point of origin. So this tool right here, fasten mate, is simply a fastener. It just attaches the two together. So I'm going to attach the end here, the center point of the circle, with the point of origin. Just want to make sure that's in the right spot. And then I click the check mark. So I've placed this here. In my assembly, the bolt is going to be stationary. It's just going to sit there. My nut is the one that's going to revolve and move up and down the cylinder. So I'm done with this. When I created the first fasten, it assumed I wanted to make another one, but I don't. So I'm going to click on that X, and then I'm going to insert the nut from my second part studio. Let's go ahead and place it anywhere. I'm done placing parts for now. Click that check mark. And now I'm going to use a special connector mate for the nut, because a nut spins, like it rotates, but it also travels up and down the cylinder. So this first, the second one in is a revolute mate, which would only allow it to rotate. Then the next one is a slider mate, which would only allow it to travel up and down the cylinder. There's a special one that we want to use called the cylindrical mate, which allows it to do both, rotate and move up and down the cylinder there. So I'm going to choose this special connector. And I want to select the center of the bottom face. So you may need to just kind of roam around it until it gets finds the center there. I'm going to click, and then again, I want this to be mated to the point of origin. So I'm going to just hide the bolt for now. So I'm just going to go over here, click on that eyeball, so I can mate it to the point of origin. I want to make sure that the Z is facing in the right direction. So you may need to orbit to make sure that the Z, or the blue line, is facing towards the top. So there's the top. I can see the red and the green, and then the blue is going in the right direction. So I'm going to click there. It's going to mate that there. Click the check mark. And now I can actually start animating freehand by clicking on it. Oh, it assumes I want to create another cylindrical mate. I don't. Press the X to get out of that. Now I can click and I can move my nut both up and down, and I can also revolve it, so get some rotational motion there. So I can do that freehand, or I can animate using the play button. So let me show you what that looks like. I'm going to right click my cylindrical mate and choose animate. Now because this can do two different motions, one rotational and the other one directional, I'm going to choose the cylindrical first, the rotational one, and then I'm going to press play to view that. So you can view that animation. It's playing on its own. It's going 360 degrees, and then it's stopping and then going in the opposite direction. I'll end that, and then I'll go back into animate. This time I'll use the one which travels linearly. And I can play that. So you can see the motion back and forth. So those are the two types of motion. What if I wanted to do both at the same time? There is a special animation. It's called a relationship. So that specific relationship is called the screw relationship. So I'm going to create a screw relationship, and it's the object that behaves in the screw, like the way it travels, rotating and traveling, is this cylindrical mate here. So I'm going to choose that. It needs to have one cylindrical mate in order to be able to have that relationship. So I'm going to click the check mark, and now if I rotate, it will automatically travel. So I can't travel up and down or rotate it without it moving in the opposite degree of travel. So there we go, there's that screw relationship. So if it travels linearly, it's going to rotate, and also if it rotates, it's going to travel linearly. Alright, so let's get into this settings here for just a moment. So we created the relationship, but we didn't really talk about the settings. So what we want is the distance traveled per revolution. In our real life scenario here, we had threads that were 2.5 millimeters apart. So with every revolution is traveling 2.5 millimeters. So I'm going to be changing this to 2.5. So mathematically it matches my bolt pattern. Click the check mark to accept that. Alright, now I'm going to reveal my bolt and go ahead, freehand screw this thing on, see if I can get it to go on the bolt. So now I have an assembly that I can animate, and it looks like a real life scenario. If I want to animate this on its own, click on animate, this point, I'm going to use the linear motion. Press play. Alright, so now it's moving away or down from the point of origin, and I want to have it move in the opposite direction. So press stop. So I want this to be, instead of 25 millimeters, I'm going to do negative. I have a bolt that is almost 50 millimeters long. When we extruded this, we extruded it inward, so there's a little bit less than 50 millimeters of play there. So let's do like 35. So we're doing negative 35. Let's press play and see what happens now. Okay, now it's being screwed on. Alright, very good. So we've reached our goal in this exercise. Hopefully you've learned a lot. This is our first kind of experiment with the assembly screen, and our next video is going to cover like a hinge motion, and then we're going to also do a ball and socket. Alright, that's it.